So complex fractions are those which have a fraction and a fraction over a fraction. So for instance, I'll start with numbers here. Let's say we have 1 over 3 minus 1 over 2 and 1 over 4 plus 1 over 2. So we have two fractions in the numerator, two fractions in the denominator, and the entire thing is a fraction. So we tackle this one step at a time. So we start with the numerator, simplify it, start with the denominator, simplify it, then go for the last or the entire fraction and simplify that. So let's start with the numerator, 1 over 3 minus 1 over 2. We have to find the LCD because the denominators are not identical. I could write 3 as 1 times 3 and 2 as 1 times 2. So the LCD for the numerator is 1 is in common. There is nothing in common between 3 and 2. So the LCD is 1 times 3 times 2, which is 6. I'll call that the numerator LCD. The denominator is 1 over 4 plus 1 over 2. So we want to find the factors of 4, which is 1 times 2 times 2, and the factors of 2, which is 1 times 2. So we have 1 in common, 2 in common, so we write 1 times 2. The last 2 is left there hanging, so we simply put that in there. So the denominator LCD is 1 times 2 times 2, which is 4. So in the numerator fractions, we want to make that denominator and that denominator to its corresponding LCD, which is 6. So we multiply and divide the first fraction by 2, and we multiply and divide the second fraction by 3. This way, we get the common LCD of 6. We do the same for the denominator. The LCD is 4, so I'm going to leave the first fraction as is. The second fraction, I'm going to multiply and divide by 2. So the numerator becomes 2 over 6 minus 3 over 6. And the denominator becomes 1 over 4 plus 2 over 4. So we have identical denominators, which is 6. So I'm going to combine it, write it as 6, and combine the numerators, and we have 2 minus 3. So I have a common denominator of 4, so I combine the numerators, 1 plus 2, I get 3. So for the numerator part, 2 minus 3 is negative 1 over 6, and the denominator is 3 over 4. Now we just have to flip and multiply. To get negative 4 over 6 times 3. There is a 2 in common, so 2 would go away. Sorry, that's a 3. Bad algebra. So our answer would simply be negative 2 over 9. So what we have here is the complex fraction because It has fractions divided by fractions, and the entire thing is a fraction. So we call it a complex fraction. So what do we do when we have expressions such as that? So we look at the numerator first, which is x plus 2 plus 2, and we would want a common denominator. The denominator there is 1. So there is nothing in common between 2 and 1, so the LCD is simply 2 times 1. We get 2. And we want to make a common denominator. We already have a 2 there, so I'm going to leave x plus 2 as is. I'm going to multiply and divide the second fraction by 2. So I end up getting x plus 2 plus 4 over 2. 2 is the common denominator, so I end up getting x plus 4 over 2. Moving on to the denominator in the original complex fraction. The denominator is x over 2 minus 2. I could write that 2 as 2 over 1. Again, there is nothing in common between 2 and 1, so the denominator LCD is 2 times 1, which would be 2. So I'm going to leave x over 2 as is because the denominator is the LCD. I'm going to multiply and divide the second fraction by 2. So I would have x over 2 minus 4 over 2. I have common denominators now. So I combine the numerators and write it as x minus 4 over 2. So we rewrote the numerator as x plus 4 over 2, and the denominator, we rewrote it as x minus 4 over 2. So let me rewrite that. So we have a fraction over fraction, so we simply flip and multiply. So the numerator is x plus 4 over 2 times the denominator, flip, 2 minus x over 4. The 2's would get cancelled, and the final answer is x plus 4 over x minus 4. This problem is very similar to the previous one. We start with the numerator LCD. We have y squared and 3y and 3 have nothing in common, so the LCD is simply 3y squared. The fraction we have, or the complex fraction, is 1 over y squared plus 2 over 3. We need to get a common denominator, which is the LCD. So I'm going to multiply and divide the first fraction by 3. Multiply and divide the second fraction by y squared. This way, when I multiply the denominators, I get the LCD. So the first fraction becomes 3y squared. Numerator, multiply 1 and 3. So 3 over 3y squared. The second fraction becomes 2 times y squared divided by 3 times y squared. Now we find the denominator LCD. There is nothing in common between y and 6. So the LCD is simply 6y. Moving on to the fraction, 1 minus y minus 5 over 6. I need 6y in the denominator, so I'm going to multiply and divide the first fraction by 6. I need a 6y in the denominator for the second fraction, so I multiply and divide by y. So 1 times 6 is 6, y times 6 is 6y, 5 times y is 5y divided by 6y. I have a common denominator now, so 6y goes in the denominator. Combine the numerators, 6 minus 5y. For the numerator here, the common denominator is 3y squared. The numerator is 3 plus 2y squared. So I'm going to rewrite the numerator as 3 plus 2y squared over 3y squared, and the denominator 6 minus 5y divided by 6y. We have to flip and multiply 3 plus 2y squared divided by 3y squared times 6y over 6 minus 5y. I see a y squared and a y, so I'm going to cancel a y, and that would leave me with an answer of 3 plus 2y squared times 6 divided by 3 times 6 minus 5y. I see a 2 or 3 in 6, so that would become 2, and that 3 would go away. So the final answer now is 2 times 2y squared plus 3 divided by 6 minus 5y. So in this problem, the numerator fraction is x plus 1 over y, which is a fraction in and of itself, so I'm going to leave it as is. So the denominator is what we have to tackle. So let's consider the denominator and find its LCD. We have x over y plus 2. 2, I can rewrite it as 2 divided by 1. There is nothing in common between y and 1, so the LCD is simply 1 times y. That would give me y. So the first fraction as x over y, so I'm going to leave that y as is because that is the LCD. Multiply and divide the second fraction by y. So I would have x over y plus 2y divided by y, have a common denominator, so that is y, and the numerator is x plus 2y. So here I would have x plus 2y over y. Now we have to flip and multiply, so x plus 1 over y times, flip the denominator and multiply, and we have y in common, so we can cancel that. So the final answer would be x plus 1 divided by x plus 2y. So what do we do when expressions have negative exponents, in other words, negative powers? We simply make everything positive and then simplify. That is the easier way. But if you have a complex fraction, though, things get complicated because, for instance, here we have x raised negative 2, which is 1 over x squared. Y raised negative 2 is 1 over y squared. We divide the entire thing by 5 times x raised negative 1, which is 5 times 1 over x plus 2 times y raised negative 1 is 2 times 1 over y. The denominator can then be written as 5 over x plus 2 over y. So we have to add two fractions, so we need to find the LCD for the denominator. So 5 over x plus 2 over y is what we have. There is nothing in common between x and y, so the LCD is xy. I'm going to multiply and divide the first fraction by y so that I get the denominator as the LCD. Multiply the second fraction and divide by x, so x over x. So we get 5y over xy plus 2x over xy. We have a common denominator, which is the LCD xy. Combine the numerators, 5y plus 2x. So we go back here. Rewrite our denominator, which is 5y plus 2x divided by x times y. Now we just have to flip and multiply. The numerator is simply 1 times 1 is 1, and x squared times y squared is x squared y squared. The denominator is 5y plus 2x divided by xy. Now we flip and multiply 1 over x squared y squared multiplied by xy over 5y plus 2x. We have an x in common. We have a y in common, so I'm going to cancel those. So the final answer would be 1 there. 1 over xy times 5y plus 2x. And that is the end of complex fractions.